In this video, I'm going to show you how to solve a system of linear equations using an elimination strategy. So the purpose of this strategy is to try to eliminate one of these variables, either the x's or the y's, by combining these equations together. And the way that we combine them is that we add or subtract them. Now, in order to do this and eliminate a variable at the same time, what we need to do is to make sure the coefficients of one of the variables are identical, or one's a positive and one's a negative, which is the situation with the y's in this equation. So if we look, the coefficient of y in the first equation is -3, and the coefficient of the y in the second equation is +3. So when these are opposite, what we can do is we can add these equations together. And when we add these equations together, we combine like terms. So we add the 4x with the 2x, which gives us 6x. We add the -3y with the +3y, which eliminates the y. So there is no longer any y's, it's 0y, which we don't really need to write. And then on this side of the equation, we also add these values. So 6 plus 12 is 18. So now we've simplified this to an equation with one single variable because we've eliminated the y's. All right, and it is important that when you combine these equations that you only combine the values on the right side or the left side of the equation, and that you only combine the values on the right side of the equation with each other. So that this is the right side and this is the left side. Now what we need to do is 6x is equal to 18. If we divide both sides of this equation by 6, we're going to find out that x is equal to 3. Now this again is only part of our solution. We need to find the y value as well. So what we would do is go back to either one of these equations. I'll take the first equation, which was 4x minus 3y equals 6. And I'll substitute 3 in for x to find the y value. So 4 multiplied by 3 is 12. Subtract 3y is 6. And if I subtract 12 from both sides of the equation, I would get -3y is equal to -6. And then if I divide both sides by 3, -3, I apologize, y will equal 2. So our solution is y is 2, x is 3, or the coordinate would be 3, 2. Now if I look at a second equation like this, if we look at b, in b, the coefficients of x are different and the coefficients of y are also different. So we can't eliminate a variable unless they're the same number and one's positive, one's negative. So what we can do here is, since I can see that the y is 2, -2 here, and this is 4, if I manipulate this first equation by multiplying everything by 2, this will cause the y values to be the same, or the coefficients of y to be the same. Now, I can't just multiply y by 2, I have to multiply the whole equation. So every part of the equation has to multiply by 2 if this equation is going to remain equal. So 2 times x is 2x. 2 times -2y is -4y. And then 2 multiplied by 7 is 14. So now my equation 1 I've changed to look like this. 2x minus 4y equals 14. It's still the same equation, it just looks different because we manipulated it. So then 3x plus 4y equals 1. I'm not going to manipulate that at all, because if you see, the coefficients of my y are the same, and one's negative and one's positive. If you want, you can also manipulate a formula by multiplying by a negative number. It is also fine if you want to get one, if both are positive. So in this situation, when I add these equations together, if you look, 2x plus 3x is going to be 5x. -4y plus 4y is 0. And then 14 plus 1 is 15. So to isolate x, I just have to divide by 5. So x is equal to 3. Again, in order to find my y value, I need to substitute this x back into one of these equations or even the manipulated equation. Any of these three would work. So I'm going to go back to the original x minus 2y is equal to 7. And I'm going to replace 3x with 3 and solve for y. So if I subtract 3 on both sides of this equation, I'll have negative 2y is equal to 4. And if I divide both sides of this equation by negative 2, I get that y is negative 2. So the solution here is 3 and negative 2. This is where these two lines will intersect. So this is the solution to the system of equations. There's one other type that I'll look at. It's one with fractions. So here's a system that has fractions. If I was using an elimination strategy to solve for this, what I would do is, if you don't want to work with the fractions at all, manipulate the equation to get rid of the fractions. So what you would need to do to each equation is multiply by the lowest common denominator. So in this case, there is only one fraction with a denominator. It's 4. So if I multiply everything by 4, this will eliminate my fraction. So 4 times 3 is 12, divided by 4 is 3. So this is 3x. 4 times negative y is negative 4y. And 4 multiplied by 2 is 8. For my second equation, if I look at this, I have two denominators, 8 and 4. So the lowest common denominator for both of these equations would be 8. So the smallest number that both will multiply to where they get the same is 8. So 8 times 1 is 8, divided by 8 is 1x. So this is x. And then 8 times 1/4 is plus 2y. And 8 multiplied by 2 is 16. Now in this situation, I need to, none of the coefficients are the same. So in this equation it's 3, and here it's 1, here it's negative 4, here it is 2. Now just to show you a difference, like I could eliminate the y's by just multiplying this equation by 2. I'm going to eliminate the x's this time. So in order to get these x's the same, but to have a different sign in front of them, I'm going to multiply this equation by negative 3. Now this isn't necessarily my first choice to do, but this is what I'll do just so it's a little different from the other equation that I did when I manipulated it. So negative 3 times x is negative 3x. Negative 3 times negative 2 is negative 6y. And then negative 3 times 16 is negative 48. So I've just manipulated this formula again, and you can keep manipulating them if you need to, but at this point I don't need to. I'm going to be able to eliminate the x's here. So if you look at this, I'm going to add these together again. So 3x plus negative 3x is 0. And then negative 4y plus negative 6y is negative 10y. And 8 plus negative 48 is negative 40. Now if I divide both sides of this equation by negative 10 to isolate y, I get that y is equal to 4. So then I need to solve for x. Now again, if you don't want to work with fractions at all, then I would recommend using one of these manipulated formulas to solve for x. So for me, look, I'm going to choose this one that I manipulated a second time. So I'm going to use x plus 2y equal to 16. And I'm going to substitute this 4 in for y. So x plus 2 times 4 is 16. So x plus 8 is 16. And if I subtract 8 on both sides of the equation, I get x is equal to 8. So here's my solution. It's x is 8, y is 4. This is the intersection point. Again, you can verify this by substituting it into both equations and seeing that it works. And if it does, it is the proper solution. In this case, to save some time, it is the correct solution.